Well, we're getting into more Beam Chevy stuff today. I just welded up these tabs, and where these are going are replacing these down here. The bypass lower mounts that go onto the beam. I cut out some tabs and had a little issue. You can see right there, actually, the shock is actually resting right up against the beam here, which is actually causing this thing, it's holding it up right there. There's a little bit of more stroke in those shocks yet to droop out. But because I, kind of took a guess, made these tabs, if you can't see, these tabs are on an angle, so it's actually two different tabs. If I line those holes up, see the distance that's off on those, to allow this thing with the right spread, it's kicked at the right angle. So a lot of guesstimation work going on in drawing up something like this. So a lot of times you just kind of got to cut one and see if it was enough clearance. And if you look there, see the little bit of gap under, you can see right there we're touching. So I made some new ones. These are a 1/4 inch longer. Each tab is a 1/4 inch longer. So it should give us now that space to let this thing actually droop down a little bit more. And we should be able to see some light in between the beam and that lower shock to not have it binding up on us. We don't have limit straps on this thing yet, but we wanna, if there's droop travel, essentially, you could put a strap on here, and more likely that's just aluminum. It would start creating a dent into that lower shock rod. It would just start denting itself. Oh, we're falling here. It would just start denting itself and clearancing itself, but we just want to make sure we give it the proper clearance right from the beginning. So that's what these are. I'm going to start taking on this bolt out, cutting those off, and then working on installing these. And while I'm at it, I've already welded up some for the other side, and then I've got another set of these for the coilovers. I don't have any of the shocks over on the other side yet. I've got this piece up here which might have to get changed. So I just put these new lower tabs on there that I just tacked them on, and just kind of was messing around with this thing and cycling, and kind of got to the point where I realized the things I kind of wanted to show in this video, I've gotten them done, and I've been able to achieve some, I guess, numbers. It's all about math. This is all just math stuff. So points and moving things around and positioning things, trying to achieve numbers. And something that is really hard to do for me, I think, is to translate to people, what am I actually doing and what am I actually trying to achieve on this stuff. When I'm saying, I'm moving this tab out, it needs to be moved a 1/4 inch, I'm kind of guessing. There's this level of guessing, but then there's also, I have to guess so many times that eventually I do get it right and I actually achieve a number I'm trying to hit. So what are those numbers and why are they valuable for different reasons? And I figured maybe I'd try to translate, since I was able to just kind of achieve that on this right now. It's kind of one of those things where it's just like, this really looks the same. It's been looking the same for several weeks as I've been working on this. Now, I run a business and I do a lot of other things. But as far as this truck in particular, I've cut, I don't know, between upper and lower mounts, probably 4 or 5 different mounts out now, moving stuff around and then cycling this thing up and down. So I figured I'd walk you through cycling this thing and kind of showing you what I'm hitting and the numbers that I'm hitting. It's almost like they're really nothing too sacred if you spend a lot of time researching this stuff and knowing why maybe these numbers are important. You can figure this stuff all out on your own. This is stuff that I figured out, and a lot of it just comes down to having a beamed truck and driving one as much as I do. I'm able to understand what's important and why things work the way they do. So my personal truck, my C10, for steering angle, there's a lot of reasons of why my truck has a very limited steering angle, but that's maybe just for something totally different another day. The steering angle on my truck, one direction, the tires only turn 12 degrees, and then the other way, the tires turn 17 degrees. So what I mean by that is when I turn the wheel, so if this is 0, I'm saying it turns 12 degrees one way, and then the other way, it turns 17 degrees. So my truck steers a little bit better, and I haven't driven my truck in a while, so I have forgotten which way that is. Yeah, I don't remember. It steers a little bit tighter radius one way versus the other. But it really doesn't have enough steering angle. A lot of factory OEM trucks are into the 20s of steering angle for driving a vehicle with the wheelbase these are. They need in the 20s of steering angle to be able to drive these things and not have a really big arc. My C10 has a really big steering arc because I only have so much time. If you've ever seen me like in a parking lot, I have to, you know, I look like the Austin Powers movie where you're bumping back and forth. That's me and my C10 because I have very, very limited steering angle. So part of building this kit, that was something that I really wanted to achieve. So right now, this is all set up to, it's all eyeballing, and I can actually grab I'm just eyeballing with a Harbor Freight big protractor. You know, eyeballing this to be 0, and then looking on here to see where I'm at. And I can position this thing between 30 and 35 degrees of steering angle, which I'll do now. And then I'll show you through the cycle of the clearance we're gonna have. So all I'm doing is that. So right there, that's only 25. So I want more like 30. So a little more. That's maybe a little more. So what I'm doing is I just turn this thing to the left 30 degrees. And actually it's, like I said, I'm just eyeballing, and I'm using the hub and the brake rotor, which is kind of centered up. There we go. Yeah, I'm like 30 to 32 degrees, somewhere in there from eyeball. And now you can see these things, you start looking at clearances. And the reason I'm going to limit this thing at about 30 and be happy with it is OEM, I was trying to find an exact number on this truck. how much steering angle this truck would have from the factory, and I could not find it. But I know 30 degrees is, if I can achieve a plus 30 once I actually set the steering stops, we'll have plenty for this thing. That'll be more than double than what my C10 can steer for steering angle. And this truck's going to be running 37s, and with 30 degrees of steering angle, the tire fits in here completely stuffed. So there's a lot of other factors going on that can't just let you, you know, one of the factors is the design with this beam kit. This is not a limiting factor. That's one of the limiting factors of the beam kit that's on my C10. These are vertical, meaning the bolts go through this way, front to back versus up and down. So that is something that's one of the reasons why this kit is designed that way. But what I'm going to show you here is, you might look and see that, but as this thing, once the stops are in, this truck, it's not going to, this pivot won't come over any more than this through the cycle. So imagine this thing, if it's turned to the left all the way on the lock and hitting big whoops or jumping or doing whatever, you probably wouldn't want to be doing stuff very fast with this thing turned all the way. But nonetheless, you jack that up and you can see that we have plenty of clearance in here. This steering tie rod, drag link, whatever you call it, is going right up in between the pivot. This pivot has room to swing in here. So we're going to keep bringing it all the way up. So now, maybe we'll pop this out of here and I can really get in there and show you. The bypass is bumped out where it's going to be. You can see we've got clearance in there. The bump still needs a pad made, and this is only tacked in, so that is very loose. That's going to get moved. And you can actually see that there's a little bit of space here, and that is because I'm about to cut out another one of these. I need to position this shock mount. That's probably about 3/8. I need to bring this hole down 3/8. So I'm actually going to redraw this whole little lip right there in the computer and then cut another one of these out. But for now, I can still show you what I'm doing. And these tabs are the tabs. This is positioned where this is going to be. They do need some weld washers welded on them like this. I double up everything 3/16 on every bolt, on pivots and suspension and shocks. So anyways, showing you that's all in there like that. And now what I'll do is, maybe I should have put this back in the camera. We'll see if I can do it one-handed. I'm going to steer it back to the right and show you the clearances the other way. Yep, okay. I'm going to put this in here. It'll be easier. We can push this over. And now I'm just going to kind of guess. I know when I positioned there, something around there. Let's pop this back out. All right, so now you can see the clearances. The bolt's not all the way in. Once that bolt's in, this definitely, it won't hit it when it drops down, but right now it might touch that when I go to drop this thing down. But you can see clearances. This is going to be kind of, this is where it's about 30 degrees now, turned to the right. And where I position this, it's going to be pretty close like that when this thing's turned full lock the other way. But still, 37-inch tire clears in here and it bumps out up here. So I'm going to actually set this back in my little holder here. And then I was going to kind of droop this thing out and show you what it looks like going through the cycle at both angles. So we'll go ahead and lower this. Like I said, that tie rod or drag link, I don't remember, whatever one that's called, it may hit that bolt, but bring it down like that. And see how it cycles. So that'll be all the way to droop. Other numbers that I mentioned, so that was the steering angle, and what I'm trying to hit was pretty much 30 degrees. Once I have stops on it, if I have 30 degrees, and now that's not 30 degrees each tire because that'd be parallel. There's Ackerman built into here, so the other tire, there's actually offset, and I'm gonna have to actually measure that. Once I get stops, I'll actually do some, I have like a little right angle fixture I made that I can put plumb bobs on, and I'll do some like chalk lines on the cement, and I'll actually get some real numbers. So that'll be a video in the future. So I'm just talking kind of rough estimates here, but 30 degrees this way. The opposite tire is going to be, and actually I'm not even going to say it because I'm going to confuse myself, but with Ackerman, your tires don't turn parallel. The inside tire will need to turn more. It needs to have more steering angle than the outside one. So that way, when you turn, it pivots better around the inside tire. So this tire, I'm setting this one at 30 degrees. That over there, right now, will be actually a higher number. So it'll probably be more like 34 to 36 degrees over there because it's turning more inside. Like I said, I'll make a video once I draw all my chalk lines on the ground, and I'll explain all that stuff in the future. For now, you just need to, I guess, understand the difference between driving my C10 and having 12 degrees one way and 17 degrees the other way. This is going to have equal 30 degrees to the left and right on the outside tire. If you're following that, cool. If it doesn't make sense to you, I don't know how to explain it another way right now. So we'll move on to the next lesson. I'm going to now turn the thing back the other way, and I'll bring the suspension up and show you the clearance from here onto that. So let's see if we can turn this back. And I might have to eyeball this one again. I don't have a good judge. Yeah, that's pretty close to 30 right there. So now if you're looking at this spot, this is the kind of the spot in question of the closest clearance. Some of the other clearances would be just the beam pivot back here and the coil spring, which I don't have the coil spring on the coilover yet. But that's something that I've measured for. But you can see, maybe let's try to actually bring you in right close and show you the exact point I'm talking about as I bring this up through the cycle. There we go. This right here, when this is turned, this is going to be the spot that, as long as everything stays welded and doesn't come apart and flex, that will be as close as that swinger ever gets to that shock. The body is bolted up top, and so the only thing that's moving is this lower point as the shaft is coming in and out. So bring this all the way back up to bump, and then I'll steer it back to center with the steering and show you what it looks like through a cycle with it all centered. So there's that thing shoved all the way up in there. If we kind of center the wheel back up or something like that, then that's kind of what it looks like. And then, let's see, we'll back it up one more time. Kind of droop it out. So the other numbers is travel numbers. And for reference, my C10, I have my C10 bumped and strapped at 18.5 inches. That's what I've been running. And it's just due to clearance issues. It's not the shocks. It's not the actual beams. It's just space. It's 35-inch tires with a stock firewall. If I remove more firewall, I could get the thing to about 20 inches. But I'm not worth doing the work. I have the shocks tuned to where I'm happy with that truck with 18.5 inches. It's fine. But more travel is not bad. And this truck, I am trying to achieve, which I'm measuring at the center of the pad of the tire. That's where I like to measure travel, where the contact point is of the tire, which I don't have on right now. But I know with this shock being 3/8 of an inch off, I'm not going to achieve the 20 inches that this will have. But all of this with the steering angle that I'm talking about, this is going to be bumped and strapped at 20 inches. So bumped and strapped at 20 inches with a 37-inch tire that can turn 30 degrees outside tire, both ways, left to right, and still has a stock firewall. So those are the numbers that are important to me, and that just comes from my experience driving my truck. And what I want to put into this beam kit for a customer of mine. So my customer has, this truck used to be an A-arm truck, and he wants a beam truck. And I've gotten to show him my C10 and what it can do. But the difference now is this kit is far superior to the kit that's on my own personal truck. And getting this out in the sand and getting it actually cycling and feeling what all that stuff equates to is going to be something that, yeah, I can only show you once I get it done and get it on the sand. So for now, I don't know if any of that made sense. I figured I kind of wanted to try a different approach on this channel. I've been doing the time-lapse stuff and just doing the work, but I've been lately kind of understanding, maybe my brain works a little bit different than, you know, most people's, but maybe there's some other people that out there and their brain works kind of similar to mine, where I'm able to draw a lot of this stuff kind of in 3D space in my brain, and then I just use the tools that I know how to use through experience of like kind of my job and machining and just being in a manufacturing industry, and applying it now to this stuff, which is for a long time was a hobby, and then I turned it into my job, and now this is what I do every day. For me though, the thing about it is this information never really gets back out. And kind of having a YouTube channel, that's kind of the point of why I started that, was to be able to kind of share and put this information back out there. The stuff that took me a long time to figure this out, in a lot of years. And a lot of it really just comes down to I've just been driving a beamed Chevy pickup for 6 years, and I do it a lot. And now I'm going to be able to put that information into this for my customers, but also for people out there trying to achieve, and you're going, okay, what's a standard that I should try to achieve while I'm building this thing and I don't have any experience? Those are just kind of some rough estimates and just rough things that I'm trying to get. You know, I won't actually know until I actually have everything permanently welded. I have the bump stops in, I have the pads in, I have the limit straps in with the tires on. I'll be able to then, I'll have to jack this thing way up in the air and cycle the thing. I'll probably put it on a lift to do that. But then I can get some real numbers of, okay, the thing is actually cycling 20 inches. It's actually turning this many degrees. But doing that, it takes all the time of tweaking this stuff to get all this stuff perfectly lined up to, if you're trying to achieve those numbers. If you're just in the process of, I just want to stick it on there and figure out and learn, well, that's a process that you can take too. But anyways, I'm just rambling. Thanks for watching my stuff. I'm going to try to put maybe some more stuff in here. If you like this kind of rambling tech stuff, I guess this is like beam math with Mr. Clean. If you like that approach, I normally don't talk this much. I can tell my mouth's drying out. But I'll try to get over it. I'll try to put more of this stuff in my videos if you like it. And if not, I'll just go back to more time-lapse stuff. But anyways, I'm going to keep working on getting these, because now that I got this done, I'm going to work on the other side and then redraw and cut out some upper mounts. And I'm actually going to be able to finally move on from the shop positioning on this thing, because I've been able to achieve all the stuff that I want to get out of this truck. So thanks for watching. We'll catch you next time. Peace.